Hello dear student, welcome to my YouTube channel. In this video we will see conjugated dienes, and there are two kinds of reactions in conjugated diene. One is electrophilic addition reaction and second one is free radical addition reaction. So we will see electrophilic addition reaction, and which has two paths, that is 1,4 addition and 1,2 addition. So we will see in the detail with the help of a mechanism. Like the video and subscribe the channel for more updates. Now let us see electrophilic addition reactions of conjugated diene. Dienes with electrophilic reagents like a halo acid give a electrophilic addition reaction. So it is similar like of an Markovnikov rule. In case of an Markovnikov rule, there was only one alkene, but here it is an diene, and we get the products that we will discuss. That is 1,4 and 1,2 kind of a product. Conjugated diene undergo the addition reaction in similar manner to an simple alkenes, but two modes of additions are possible. And consider now a reaction of that is 1,3-butadiene. 1,3-butadiene, when it is added to an halo acid, it gives 1,2 addition product and 1,4 addition product. Now we cannot say which is major and which is minor. It depends on some of the factors that which will come major and which will come minor. As you can see that 1,3-butadiene, it means that at number 1 position it is having a double bond, and at number 3 position it is having again a double bond. So that is why 1,3, and butanes, there are 4 carbons and it is having a 2 alkene bonds, and that is said to be a diene. And after addition we get 1,2 addition product. 1,2 addition means what? That hydrogen it is added at carbon number 1 and bromine it is added at carbon number 2. So that is why it is said to be an 1,2 addition product. And if we see the next structure, that is 1,4 addition product. In case of an 1,4 addition product, the bromine it is added at carbon number 4 and hydrogen it is added at carbon number 1, and the double bond it gets shifted between carbon number 2 and 3. So that is why it is said to be a 1,4 addition product. Now we'll see the mechanism why this 1,2 addition product it is been forming and 1,4 addition it is been forming. It is also having some reasons behind it. Now let us see the mechanism. In case of a mechanism, see this 1,3-butadiene it will react with an halo acid. So one of the double bond it will react. So whatever the double bond that will react, we will consider that double bond as number 1. So if it is reacting from this side, we will consider that double bond as number 1. Double bond, pi bond between carbon number 1 and 2 it will break, and it will abstract the hydrogen, and at the same time bromine it will carry away electron with itself and it will have a negative charge, and partially the hydrogen it will have a positive charge. As it is electron deficient center, now it is under attack by this pi electrons of an alkene, and this it is a resonance hybrid that which has been formed. See now this hydrogen now which accumulates at position number 1, it can be seen in the red color. This resonance hybrid it is equivalent to this carbocations. So there are two kinds of an carbocation that are been seen. As carbon number 2 it becomes electron deficient, and carbon number 1 due to an addition of an hydrogen it is been now satisfied, it is having number of valency, that is 4, it is having 4 bonds, but carbon number 2 it is having only 3 bonds, 1 hydrogen in between, and this carbocation which is being formed. So it is these are resonating structure. It is indicated by an arrow that these two are resonating structures. So carbon number 2 with the carbocation, that is more stable carbocation. Bromine will attack at position number 2 as it is electron rich. Here we have seen that bromine is carrying away an electron with itself and it attacks the carbon number 2. And in the second carbocation is that this bond it has been shifted from carbon number 3 and 4 to carbon number 2 and 3. So it has been shifted that after a shift it forms a carbocation at carbon number 4. As there are only now 3 bonds with the carbon number 4, it will form a carbocation. So bromine can attack at carbon number 4 position also. but it is least stable carbocation. As per the thing that carbocations, the more stable carbocation that will give alkene, and again least stable carbocation that will give an alkene from an diene. But now next thing is that least stable alkene from a more stable carbocation, least stable alkene, it has been formed, and this product is said to be a kinetic product. And if we see the second, which forms an least stable carbocation, it forms a more stable alkene, as we have seen in the earlier session in case of a Z rule. So that Z rule, it was indicating that when carbon, the double bond, it is having a number of substituent more, or number of more substituents, so that alkene, it will be more stable. So this double bond, it is having substituent on the both sides, so that is why it is more stable compared to this one, compared to earlier one. So the thing is that more stable carbocation gives a kinetic product which is less stable alkene, and least stable carbocation gives a more stable alkene, that is thermodynamic product. So thermodynamic means there is some involvement of a temperature over here. So we will see that why it is said to be a thermodynamic, because energy of activation required for to form a least stable carbocation, it is more, so that is why it is said to be a thermodynamic product. And as you can see that attack, there is addition of an at 1 and 2 position. So hydrogen, it is added at position number 1, and bromine, it is added at position number 2. And you can see that red color hydrogen, it is added at number position 1, and bromine, it is added at position number 4. So that is why it is said to be an 1,4 addition, and it gives more stable alkene. Now which of the product do we get in the major quantity, whether it is a kinetic product or whether it is a thermodynamic product? So it depends on the conditions, what kind of conditions that we are running for in reactions. So let us see that which product it is predominated, that is 1,2 addition product or 1,4 addition product. So stability of an carbocation, first thing is that is stability of carbocation. The addition of proton occur as per the Markovnikov rule. The stability of carbocation will be formed to be at the more substituted carbon and form 1,2 product. Because the stability, as per the stability, we will get 1,2 product, as we have seen that more stable carbocation, that is secondary carbocation, which is been forming in the diene. So that is why we get, as per the stability, we should get, and as per the Markovnikov rule also, we should get 1,2 addition product. If we see the rate of reaction, the energy of activation for the formation of 1,2 product is lower, and hence it is fastly formed. So that is why it is said to be a kinetic product. At lower temperature, it has been formed because energy of activation, it is required low, and that is why it is formed fastly. However, the equilibrium is favored for this 1,2 only. 1,4 product require high energy of activation, but favors equilibrium. So equilibrium, it is less favor for 1,2, and for 1,4 it is more favor, but energy of activation, it is required because means heat, it is required for the purpose. If the drastic condition of heat we are giving towards the reaction, then we will get 1,4 product instead of 1,2. Again, now the point, that is reaction temperature. So energy of activation, it can be increased with the help of this reaction temperature. So kinetic product which appears first in the reaction, but stable product is thermodynamic. So that is 1,4 product which is stable, and 1,2 it is unstable, means less stable alkene that we get from unstable carbocation. 1,2 product is formed first at lower temperature, but rearranges to 1,4 product at high temperature, because 1,4 product is more stable alkene. As we have seen that the alkene, it has been surrounded by the carbons, and as it has been surrounded by the carbon, it means that it becomes more stable. As alkene gets substituted, stability increases. We have seen in the Z rule also. And if the now the point, that is reagent, use of milder condition gives mixture of product. Use of excess reagent results in 1,4 product. Right? Use of excess reagent gives an 1,4 product. So these are the four conditions whether which product will predominate. As per the stability of carbocation, 1,2 should predominate, 1,2 addition. Rate of reaction, if energy of activation is low, then 1,2. If energy of activation is high, then 1,4. Rate of reaction temperature, when it is low temperature, it will be 1,2. When the temperature it will be high, it will be 1,4. And if excess of reagents are been utilized, then it will be 1,4. So these are the cases by which whether it will be 1,2 or 1,4. If you are having any doubts, you can comment me in the comment box section. Thank you for watching the video.